Alright, let's talk about area and volume. So what I did first is I identified on my graph which curve is which. So I know root x looks something like that, so this must be the other one. And then I have my x equals 1 as a vertical line right here, x equals 1. I know this point itself is 1, 1, because if I plug 1 into y equals root x, then I get y equals 1. And then this, I know I need that as an intersection, because later when I find the area or the volumes in terms of x, or even if I need it in terms of y, I need this x value or this y value. Okay, so that's the first thing that I actually did on the calculator. And then I'll show you right here if you can see it. So on the calculator, I already plugged that in. I graph it. I actually set my window from 0 to 2, from 0 to 2. Otherwise, I won't be able to see very much. And you can see over here they give you, it goes to 1, it goes to 1. So I went all the way to 2 just to see what's going to happen. So I have another video up that shows you exactly how to calculate the zeros and the intersections. But for this one, I'm just going to show you real quick. I go down to intersect, or I just press number 5, and then you start on the left side of the intersection. See that little spark? So you press enter, and then you go to the right, so you press enter, and then enter one more time. It gives you the intersection, which is point blah blah blah, point blah blah blah. Okay, so that's what I have in my very first step right here. So you can see the intersection of these two curves is, and I wrote down pretty much the whole number that I got from my calculator. This is what they're going to be looking for, and this is my lower limits. And if I want to find the area, so A was find the area of R, and if I wanted to find the area, I'd do top minus bottom, which means that I need x values as my lower limit and my upper limit. Okay, so what I did is I put let A equal this number. That way I never have to write that number again. I can just write it one time, I'm done. And when I do the problems over here, when I rewrite it, then I just write A instead. Okay, so a little time saver. And then again, this is going to be top minus bottom. So we saw in the graph, this was the top curve, this was the bottom curve, top minus bottom. Make sure that you have all this, and then you put into your calculator, you got a final answer. These units don't matter so much, but sometimes the units do matter, so just kind of be careful. Okay, the second question is, find the volume of the solid generated right here. When R is revolved around the horizontal line y equals 1. So that's why I have that y equals 1. So if we revolve it around this way or this way through the back and coming up and forward, we're going to get these donuts or washers basically. So for a donut or a washer, when I'm revolving around a horizontal line, I'm still in terms of x, and I know that my formula for that is going to be pi, and then big R squared minus little r squared, and then again in terms of x. Okay, so this is pieces of circles and then going all the way around, and it's basically like big circles minus little circles, so that's why it's pi, and then big R squared minus little r squared. Okay, so I wrote my formula first, but really I just wrote this so that I have a template. Here's my pi. My x coordinates are still the same from A to 1, and then my big R is 1 minus, so this is top minus bottom from my axis of symmetry all the way, like this is what I'm revolving around, and then all the way to the furthest away point of my curve. So basically this is big R, that whole thing, and this would be little r, so 1 minus e to the whatever, and then 1 minus the root x. So you can see right here, you have 1 minus, that's my big R, 1 minus, that's my little r. Everything is in a bracket in terms of x, and then you put that into your calculator, and then you get that final answer. You can truncate, which means just stop after the third digit, or you can round that third digit. It's up to you, but you need to go out to 3 digits at least. Okay, for the last part of the problem, for C, It says find the region R of the base of the solid. For the solid, we have cross sections, and those cross sections are perpendicular to the x-axis. If we're perpendicular to the x-axis, then again, we're in terms of x, and then we want rectangles. Okay, so right away, rectangles do not have a pi. The formula for the area of a rectangle is base times height. And then it says the height is 5 times the length of the base in region R. Okay, so that's the first step that we did. So base, and then the height is going to be 5b. So I simplified a little bit, but maybe I shouldn't have. So this is b, and then 5b, which gives me my 5b squared. So all I did is I replaced, excuse me. And then because I'm still in terms of x, I'm going from a to 1. Here's my 5. Here's my base, which is top minus bottom again, just like in A. And then squared is right here. This whole thing is worth 2 points. And then final answer is worth 1 point. Okay, so there you go. Good luck.